Okay, let's get started with it. So today we're going to talk about, well, last time we talked about sets. What is a set? How do you represent a set? How do you talk about sets? So now we're going to talk about Venn diagrams, or as I like to call them, pretty pictures of sets. All right. Sorry? That's part of it, yep. Okay. So what the heck is a picture of a set look like? Here we go. This is the basic idea. So what are we looking at? Well, first of all, we've got two sets here. And the sets are called A and B. Now, what's typical when we draw a Venn diagram, which is a picture of a set, we also like to draw a big box around everything and call that the universe. Now, what elements are in set A? 1, 3, and 5. Ooh, hello. Now, what elements are in set B? Now, to figure this out, you look at the circle that represents the world of set B. What's inside there? Which elements are inside there? Is 1 in there? Is 2 in there? 1. Yeah. So it's 1, 2, 3, 4, 5. Now this picture also makes clear a relationship between set A and set B. One of the relationships that we talked about last time. What's the relationship? Right. So I'm glad you said that, because that brings up one of the things we talked about last time. Do we say that A is an element of B, that set A is an element of set B, or that set A is a subset of set B? It's a subset, exactly. Because that's how you compare sets. Yeah, it's sort of, it stands for contained in, but another way to say that is subset. Yes. Yes, like that. Okay. So the formal definition of a subset is to say that A is a subset of B if every element of A is also an element of B. So for example, in this example, what are the elements of A? Sorry?
1, 3, 5.
1, 3, 5. Are those also in B? Yeah, of course, like we just said. Therefore A is a subset of B. Now, there's another way to write this down, which is like this. So what's the difference between what was written before and what I'm writing now? Well, this also says subset. Actually, let me also ask you another question. Is set A a subset of set A? Is it true that every element in A is also an element in A?
Yeah.
So it's a subset. But they're not equal, exactly. So we need to come up with a way of how do we write that down in notation. proper subset. A proper subset is a set that is, it's a subset, but it's not the set itself. So for example, is A a proper subset of B? Is A a subset of B, but it's not the same thing?
Yeah.
Yes. Now, is A a proper subset of A? No, because it's a subset, but it's the same thing, so it's not a proper subset. So how do we write that down? Put a slash through it. So again, notice the slight distinction between these two notations. Just writing the C, what that really means is proper subset. And then you can also write the C with the line under it, and that means just a regular subset. So it could be the set itself. So keeping this in mind, what's the relationship between set set B and U, which, if you recall, was the entire universe?
So B is a subset of U. It's a proper subset of U.
B is a subset of U, and B is a proper subset of U.
Wait, so proper, no line, or line?
That's a good question. What does this notation remind you of? This should remind you of something from arithmetic. Yeah. Not equal and not equal, and also what else? What does this little C kind of look like? It's not the same. It's not the same as, but it kind of looks like. Yeah. There you go. Now, again, obviously doesn't mean the same thing. We're talking about sets. But to answer your question, what means what, this is sort of like a helpful reminder in case you forget of what means what.
Greater than 1, yeah, I get it.
Okay, and of course, A is not a proper subset of A in the same way that 3 is not less than 3. So it's the same idea, but now we're applying it to sets. Any questions about that? No? Okay. So here's the first example. There's set A. A contains little a, C, and E. Which of the following is a subset of A? Which of the following is a proper subset of A? So which of these are subsets?
D. D is a subset.
D is a subset. What else?
F.
And F. Okay, is E a subset? No. Okay. And D is a proper subset. Anything else?
F was a proper subset, isn't
Is F a proper subset?
it? Wait, what is a proper subset?
Yeah, what
Can
is
you
a
go
proper
that over again?
subset? It's a subset, but it's not the same thing.
Oh.
So what do we say about D? Is D a proper subset? It's a subset, but what can you say about it? How do A and F compare?
It has the same number.
They're the same thing. So is it a proper subset? Nope. Because it's equal. And for a proper subset, it can't be equal.
So for it to be a proper subset, what would it have to be then?
Like D. Like set D. Is set E a subset?
No.
No. Right.
Also, as long as it contains like something else, the thing is going to be a proper subset. Yeah, I mean, like,
Yes.
let's say one of them was like a C and an E. It would have been a proper subset.
Yes. All right. So now, all those things that we said about these being sets and proper subsets and proper subsets or not, how do we write down all those things in the proper notation? So we said that D was a subset and D was a proper subset. How do you write those things down? Flip it around. And what does that say? D is a proper subset of A. So just to also remind you, you could also say that D is a subset of A. Okay. Now what about for set E? Yeah. And of course we can also write that E is not a subset of A. So E is not a proper subset of A, and E is not a subset of A. Now what about for F? Is this true? No, this is not a proper subset. I got to put a slash through it. But what about over here? Is this true, or do I have to put a slash through it? This is true, exactly. Okay. So, next. What if a set has nothing in it? So to continue with the example from last time, Chris. Poor broke Chris has no toys. The set of Chris's toys is the empty set. So how do we what's the notation for this? How do we write this down? Well, there's two different ways. You can either write we use the curly brackets to denote a set, so you can simply write curly brackets with nothing in there, or the shorthand notation is to write a 0 with a slash through it. Both of those mean the empty set, a set with nothing in it. Now, what's a subset of this set? Can you make up another set that also has this these elements in them?
Anything that doesn't have nothing in it.
Anything that doesn't have nothing in it, that's right. Which means you have what?
Nothing. No elements.
Right, and what do we call that? Exactly.
Or what?
So the only subset is the empty set, because as soon as you have an element there, it's not a subset of the empty set. Now here's a thinking question. What are the proper subsets of set C, which is the empty set? Right.
So wait, you write a proper set.
There aren't any. Because the only subset of the empty set is what? Is the empty set. So the only subset is the set itself. So are there any proper subsets? A subset that is not the set itself? Nope. Okay. Okay. Any questions on these things so far?
Yeah, what is that? The C with the line in the middle, that's like not a subset of?
Exactly. Yeah, we put a slash through to mean not. Just like equals, not equals, this is proper subset, slash not a proper subset. Yeah.
Equal is a subset equal to?
Yeah, C with the line underneath it means subset. But notice that C with no line specifically means proper subset. Does that make sense? Okay. Okay. Next. So take this set. What are the elements of this set?
A.
A. Okay. What are all the subsets? Okay, there's the set with A in it. Are there any other subsets? The empty set. So notice that the empty set is always a subset.
Oh yeah, the empty set is like the universe, right?
It's like the opposite of the universe. It's like the black hole in the middle of the universe. Okay. So these are all the subsets, and there are two of them. Next, take this set. What are the elements of this set?
A and B.
A and B. What are all the subsets?
A and B.
Okay, what's one subset? A. What's another subset?
B.
B. What's another subset?
And
A, B. What's another subset?
B. BA.
Are A, B, and BA different sets?
It could be.
Is it the same collection of stuff or a different collection of stuff? Same collection of stuff, so it's the same thing. So far we got A, we got the set with A, set with B, set with AB. Anything else? Empty set. Are there any others? That's it. So there are 4 subsets. Okay. Now here's a fun one. What are the elements of this set?
A, B, C, A, B, B, C, A, C, empty set.
You're mostly right. Let's see. So this set has A, B, and C in it. So what are the subsets?
A, B, C.
A is a subset, B is a subset, C is a subset. A, B is a subset, B, C, A, C.
Empty set.
And A, B, C, and the set itself. So altogether, how many is that?
1, 2, 3, 4, 5, 6, 7.
8.
8 is right there.
Yeah, I know.
Wait,
Yeah.
8 is not a
How come the set itself to be a subset?
The set itself is a subset, but it's not what? It's not a proper subset.
But AB is a proper subset.
Exactly. Because remember, what is a subset? A subset says if it's in this set, then it's in the original set. So if you look at the set itself, if you look at every element, it's in the original set.
I don't understand why you use this. I don't get it. Like you need a set to be a subset as well.
Because it's in the set.
So right. So the distinction is what you're thinking of, I believe, is that it's not a proper subset, which is true. It's like saying how can 3 be less than or equal to 3? Do you understand why 3 is less than or equal to 3? Because being equal is okay. Same thing with subsets. Another way to think of it is that there's no element that's not in the original set. Which, if you have the same set, that's certainly true. Okay. So hopefully that clears it up. If not, after you work on the homework, you can come back next time and ask some questions, and we can still talk about it some more. All right. So what's the pattern? As far as the number of elements in the number of subsets, what's the pattern?
Just multiply by 2.
Every time you multiply by 2. So if I gave you a set with 4 elements, how many subsets are there?
10.
16. If I gave you a subset with 5 elements, if I gave you a set with 5 elements, how many subsets are there?
5.
2, 4, 8, 16,
Oh, that's how the 32.
32. If I gave you a set with 6 elements, how many subsets are there? 64.
Got it.
Okay. Now, what if I said I'm going to give you a set with 10 elements? How many subsets are there? Well, you could either go 2, 4, 8, 16, or you could realize the shortcut. It's just the number of subsets is 2 to the n.
Okay, 100.
10 elements gives you 1,024 subsets.
How's that 2 to the n? Oh wait,
2 to the 10. Notice that 2 to the third equals 8, for example. Okay. Right? So one element gives you 2 subsets, 2 elements gives you 2 times 2, 3 elements gives you 2 times 2 times 2, etc. So now here's a fun follow-up question. If the number of subsets is 2 to the n, what is the number of proper subsets? Well, what does it mean to be a proper subset?
it contains all the numbers.
It means it can't be itself. There you go. Because you want to count all the subsets except the set itself. So there's one set that you don't want to count, so you just subtract one. Now, just a little bit of philosophy. You can go around memorizing all these formulas, but so for example, there are 2 to the n subsets and 2 to the n minus 1 proper subsets. So you can either think of this as 2 formulas I have to memorize, or you could think of it as one formula to remember and another formula that just makes sense. Because if you understand what a subset is and you understand what a proper subset is, then once you remember that there are 2 to the n subsets, how many proper subsets do there have to be? Just minus 1. Okay. So, any questions about that? Okay. Okay. So, we started by talking about Venn diagrams, and we're going to finish. Now that we talked about subsets, we're going to finish by talking about Venn diagrams. Okay. So, our universe is, all the counting numbers from 1 to 10. And set A is the set 2, 3, and 5. Now, what is everything? Again, when I say everything, I mean everything relative to our universe that is not in A.
1, 4, 6, 7, 8, 9, 10.
Exactly. So this has a name. This is called the complement. So what's the notation for this? There are 2 different notations for this. A prime or A with a bar over it. Both of those mean complement. A prime, A with a little mark, apostrophe. Okay. So, next. Let's think about the set B. Here's set B. 3, 4, 6, 7, 8. So first of all, what is n of b? Right. Because what is n of b? What is that asking for? Exactly. The number of elements in B. So this is just 5. Next, what is B prime or B complement? Okay. And of course, since we're writing down a set, what do you also have to write? Oh, okay. You should write B prime equals, and what else should you write so that we know that you're writing down a set? The curly brackets. Curly brackets make it a set. Is A a subset of B?
No.
No. So how do we write that down?
A/C/B.
There you go. How many subsets does B have? And how did you get that?
2 to the 5 power.
So how do we figure out how many subsets there are?
2 to the power.
Exactly. It's 2 to the 5th. And what's 2 to the 5th?
32.
Check it, it's 32. I'm counting all subsets. Okay. And now we're going to draw the Venn diagram for this picture. So first of all, well, it's standard practice to write a U in the corner to say that's my universe. Okay. Now, how do we set this up? Well, you have to draw one circle, and that's set A. Now we want to draw another circle for set B. How do I draw this second circle?
You're gonna have to draw it kind of contained in A. Because
Contained in A like this?
No, like sharing part of A then. Sharing part of A.
Right. Notice that you can't draw it like this because what would that mean? That would mean that B is a subset of A. Is that true? No. Now, I could draw B over here, but then there's going to be a problem. Yeah, because they have 3, they share 3. If I draw the picture like this, can I show that they share 3? No, I can't. So the way to draw this is like this. Now notice that they share 3, so where does the 3 go? Goes in the middle. There you go. And what else goes where? Okay. So 4, 6, 7, 8, and then what else? Remind ourselves what A is.
2 and 5.
Okay. 2 and 5.
And everything else goes outside of
And where do 1, 9, and 10 go?
in the universe.
They go in the universe outside of A and B. Does that make sense? Okay. So what we're going to talk about more next time right, is, for example, 3 is what they both have in common. Now there's a name for that. In English I'm going to call it the overlap, but the fancy math term for that is the intersection. But again, that's something we're going to look at intersections next time, along with other things like complements and unions and all that sort of stuff. This was just an introduction into basic Venn diagrams and how you represent them. Okay. Any questions? Okay.